All right, moving on, we have Dr. Rachel Rotz. Rotz, I never like saying the thing. Understanding nutrient loading in a hydrologically sensitive coastal watershed, the Peace River Watershed. And the purpose is to share results from a recent Florida Gulf Coast University study focused on nutrient loading in the Peace River Watershed. And the CCNP connection is this relates to water quality improvement priority action 3 to reduce urban stormwater and agricultural runoff pollution. So,
thank you. Hi, I'm Dr. Rachel Rotz. I'm from Florida Gulf Coast University. I've been at FGCU started my 5th year this semester. I'm a hydrogeologist. I'm actually a trained geologist, and I have interests in groundwater surface water interaction. I also do a little planetary analog groundwater work on the side when I'm not super busy. And then within the past few years being at FGCU, I'm really getting involved in surface water quality projects, as we all are, and we understand this is a pretty important topic for our region. So I'm going to talk to you guys today about a little bit about a paper that we just published this year that Ariel introduced the talk as Understanding Nutrient Loading in a Hydrologically Sensitive Coastal Watershed, the Peace River Watershed. But what I'm really also kind of showing you guys today is a methodology that the several teams at FGCU, as well as other partners, are developing right now for a watershed assessment approach. And so we are using the Peace River Basin as a pilot study, and there's a wealth of information that we are compiling and insights that we are making as we're working through the watershed, and also sort of creating this sort of methodology where we can step into other watersheds. So I'm going to give you a little bit of an overview about that pilot study, the concept or the approach, the methodology that our teams are developing, including a model that we set up for the Peace River Basin. So I'll present those results to you, which is in the paper that we published. And I'm happy to share this paper with anybody after the meeting today. I think Nicole has a copy of it as well. And so if anybody would like a copy of that, happy to share that. And, you know, we did a water quality comparison along with the model. And one of the reasons that we're doing this is to identify not just hotspots in the water, but hotspots on the land for surface loading of nutrients, so that we can present some different project recommendations to DEP and the legislature, including a cost benefit analysis along with those project recommendations in order to help support the state efforts and the regional efforts for water quality. And so the idea is that with this methodology, we can scale up into other watersheds. And so the Peace River Basin was the basin that we are using for our pilot study. To give you a little bit of a background about how this all came to be, this work was initially championed by Senator Ben Albritton, who's a citrus farmer in Peace River Basin. He's now the president of the Florida Senate, and he really wanted to understand what was happening with the water quality in the Peace River and really dig into the data specifically to get some insights about this. And this project was actually initiated with UF. And the first year into the project, there was some kind of a problem. And FGCU at the water school was actually approached by an external partner, a technical partner, about picking up where this project had kind of left off. And so the water school was approached, and we put a team together, and we created a scope of work that we proposed to DEP in 2023 to kind of pick up where UF had left off to continue this work. And so we put a few different teams together, and we got the grant agreement executed with DEP, and we started to do work on looking at these different parts of the Peace River Basin. We're working currently now with the School of Entrepreneurship. We have people over in the engineering school. We have a technical partner, SAS, which is a statistical analysis software company, and we're also working with USF, as well as a couple of other consultants in the area to put all of this work together, and it's pretty extensive. And so I just want to kind of show you a roadmap, and this was developed kind of off of the back of what UF had started. And so we have all these different nodes to the research. And so the way that the work was initially going to be approached was to kind of have the sort of conceptual model developed of a watershed, particularly Peace River Basin, put together some kind of a model, whether it was a surface runoff model or a hydrodynamic model, identify hotspots, look at data gaps, look at potential for experimental in those regions, and then put together priority areas, and then take a look at those areas and then set up different scenarios and run those scenarios through the model to look at the environmental benefit, look at the nutrient reduction, compare that with the costs of those projects, and then make recommendations. And so, we kind of always say with this first watershed that we were sort of flying the plane as we built it, because we were really just trying to put together a methodology to be able to do this for other watersheds, also start to understand the watershed, understand all these different pieces of the methodology, and put it together in a way that was meaningful for FGCU's teams, that was meaningful for what the legislature wanted, and that was also meaningful for what DEP wanted out of it as well. And so what I'm going to show you today is kind of what has come out of that so far, where we're at with it, and where we're going. And so one of the first things that we did is we sat down with Dr. Barry Rosen, who studies harmful algal blooms at FGCU in the water school. We put together a comprehensive list of all the drivers that influence algal blooms and, in general, estuarine sensitivity. And we looked at the drivers, the forcing functions, the sources and stressors, and then the metrics that measure all of those things. And we tried to sort of get a comprehensive look of all of these different processes that are occurring within a watershed that are contributing to high nutrient loading and problems. And he would say that this science is actually more complicated than rocket science. And I know we're missing even a lot of the biological factors that go in here. But as we all know, because we're doing this work, this is a pretty complicated nut to crack. And part of the that came out of looking at this was just really trying to understand what were the sources of data available that we could potentially use in our model that could help us, identify these hotspots. And so what I have kind of highlighted there in the red box is, the data considerations that at in terms of our analysis. And so we use obviously several of these data sets into our model. The team landed on choosing the watershed assessment model. So this is a particle tracking surface runoff model that we did for Peace River Basin. So we are using the Huck 8 boundary for Peace River Basin. And the idea is that you take several different data sets, you layer them together, and you can compute on a gridded cell. And in this case, we're on an acre scale, acre by acre, the nutrient generation, and then the mobility of that nutrient, in this case, total nitrogen and total phosphorus, through the system, through the soil, into the shallow groundwater, all the way down to the water's edge, whether that's the main Peace River or one of the tributaries, and then calibrate that model against the water quality and the flow in order to actually model nutrient generation on the land itself. So we're not actually looking at hot spots in the water, we're looking at the hot spots in the land. And so this model's actually been developed by a consultant soil water engineering team. It's led by Del Botcher. I don't know if you guys know Del, but he's been doing work in Florida for more than 40 years. This model is kind of his brainchild. He's been developing it for all of that time, and it's really kind of fine-tuned for the flat topography of Florida, the canal systems, and our really high water table. And so there are other surface water assessment tools out there that do this sort of particle track work. This one is one that's been well developed and well oiled over more than 3 decades for the actual physiography of Florida. And so I'm just going to jump right into the actual results of that model. And so these are the results from the Peace River Basin. And so I'm going to try to walk you through. Let me see if I could get this pointer to work here. Yeah, I'll try to walk you through a little bit of what this map is showing. So this left map of the Peace River Basin, this is the total nitrogen loading here at an acre scale. Okay, and I guess this is at hectacre for this particular GIS map. And so the red colors show the higher total nutrients, total nitrogen loading, and the blue is the lower. And then this map here on the right is the total phosphorus loading. Again, red is higher, blue is lower. This third map here shows groundwater nitrate loading, and this is part of what that WAM model actually generates. And then the fourth model here is showing you total nitrogen to total phosphorus ratio. And so this is what we call our base model output map, and this is basically 23 years of data that has been compiled. It's a combination of the topography, rainfall, temperature, soils, water table, land use, septic distribution or wastewater. There is best management practices considered in there based on enrollment, irrigation sources. There's also hydraulic structures factored in here, discharge from permitted wastewater sites, stream flow, nutrients, TN and TP measurements from in the water, and then also all the water bodies from the NHD data set. And so this information that you're looking at here is modeled TN and TP on the surface for the 2024 year. All right, so the culmination of all those years of data to model the current year. And you can get this information out of the paper, and those maps that I just showed you are also in that publication as well. And so one of the things that comes out of the model is we're able to actually look at land use and actually look at what the percentage or the amounts of loading by land use type is. So you can see there that the urban land use areas have generated the highest amount of nutrient loading for total nitrogen and also for groundwater. But as you can see, that mining and reclaimed mining lands are generating the highest amount of total phosphorus for those types of land uses. So this is a really interesting piece of data that can be used for best management action planning. It could also be used for recommendations for projects or just getting an understanding of actually what's happening in the basin and looking at this change over time. We also looked at water quality, so we didn't just ignore it altogether. Now, keep in mind, the model is calibrated off of that water quality, but we also looked at the water quality data itself. These are two pretty crude GIS maps of historical water quality relative values between 2015 and 2023. This data is all from EP's WIN database. And, as I said, it was kind of crude, but what I want to kind of point out to you here is that we see the highest concentrations historically of total nitrogen in the upper part of the Peace River, just south of Lake Hancock, which is pretty much the headwaters of the Peace up there. And then what we see for phosphorus is we see this really high concentrations right through the heart, right, of the Peace River, just south of where we have a high amount of mining activities there. And so we did look at water quality. We looked at it a couple of different ways. This is one of the analyses that we did. The model also can generate, and it modeled the amount of nitrogen and phosphorus loading that came out of some of these different sub-basins or these Huck 10 scale basins. And so the way that the model worked, it was kind of coupled. It did the upper Peace River part first, and then it took the output from the upper Peace River and brought it into the lower Peace River. And so it's actually quantified the TN and TP loading in the water by these Huck 10 scales. And you can see that the Peace River, just from the upper part of the Peace River is bringing in quite a bit of nutrients. And then we also see a lot of nutrient generation as we move through. The other thing I also want to point out about this study is that the model was able to actually model and calculate the total export to Charlotte Harbor in terms of the amount of water and the amount of tonnage for total nitrogen and total phosphorus. Now, I don't know yet how this looks relative to other basins. And so one of the things that I want to do is I want to take this information, and as we're building out these models for these other watersheds, start to have a relative understanding of what this means in terms of its magnitude, in terms of the size of the Peace River basin, and what these volumes actually look like even on a national scale with other estuaries that are having the same issues. And so I think this is a really important piece of information that we need to look at closely and think about how this measures up against other basins and what we can do with this information when we're asking for funding and support for different things. So as I mentioned, the goal was to kind of find some hot spots, right? So this is methodology that we're trying to create, that we're working on. And so based on the nutrient outputs, with the base model output from the WHAM model, we looked at where the upper 95th percentile of nitrogen was being generated within the basin. And we tried to look at different land uses, anthropogenic activities that could kind of point to opportunities to think about different kinds of projects that we could recommend that could either mitigate or deal with some of the high nitrogen loading. And so one of the things that we looked at were the agricultural areas and BMP enrollment, right? So we know in the Peace River Basin that BMP enrollment is voluntary at this point. And yes, there are some issues with whether or not those practices are being followed, and we don't really know. But based on if we're taking, that enrollment data on good faith and that those practices are being followed, we found opportunities for some areas where BMP enrollment was not happening in high nitrogen generated areas, where if there wanted to be an effort to go back to those farmers and say, hey, could you guys do BMP enrollment? These would be targeted areas where we could actually go back, look up those places, and champion that enrollment for those areas. We also looked at urban development. And one of the things that we found was we found a lot of high nitrogen generation, surface loading on land, in addition to the water quality historically having high nitrogen. These priority areas up in the northern part, most of the basin in Polk County. And I want to kind of highlight this really kind of thicker red spot here, which is just right next to Lake Hancock, which is where we saw those historically high water quality values for total nitrogen as a potential hotspot. And then we also looked at the septic priority areas. We looked at the septic tank density and septic tank distribution. And we also identified this northern part having the highest density of septic, being the most vulnerable area for nitrogen contamination from septic tanks. And so we started to kind of focus in mostly on the sort of northern part of the Peace River Basin. We do see some things in the mid part of the basin with Wauchula and Arcadia. And then obviously we see some things down in the harbor in terms of high density septic as well down there. And so I just want to talk about BMP again really quickly. So as I mentioned before, we did find some areas that could benefit from additional BMP enrollment. That's all these little highlighted areas that you see in pink here. These were where we saw high nitrogen values with very little BMP enrollment there. One of the things that we did compute was how much of the agricultural land use actually enrolled in BMP. And we found that nearly 75% of the agricultural lands already participate in some kind of BMP program. And so I think that, while we did target some opportunities for BMP adoption for this particular basin, we really found that the septic tank and the urban development were kind of the areas that we wanted to hone in on more for the total nitrogen generation. This last set of maps here just does show that we did run the scenario analysis through the model for the BMP enrollment to calculate how much nutrients we could pull out of the system with enrollment. And we did compute, and you can get this information in another paper that we're going to be publishing that is just based on scenario analysis, where we'll show how much savings and nutrients come out of adding those additional BMP enrollments into the system. The other thing that we looked at for the potential scenario analysis is what happens if we went ahead and implemented wetlands into some of the areas along the Peace River. And so this work was done again with the SWET consulting group and a couple of other independent consultants that worked along with SWET to sort of identify some opportunities based on the total nitrogen and total phosphorus loading that we were seeing with the WAM model, as well as the historical water quality data. Where would there be really good opportunities for wetland implementation? And so we identified, I think, as much as 6 locations for wetlands to be implemented. Most of these were already on publicly owned parcels, although one of them was on Mosaic's property. And so this is, again, just sort of a way of showing how we can sort of find these targeted opportunities for projects to make recommendations to help mitigate the nutrients in the waterways, and then, you know, do a scenario analysis where we can actually go put these wetlands into the model, rerun the model, see how much nitrogen and phosphorus is captured out of that model, and actually show that savings or that reduction if we were to implement these projects. The other thing is the septic tank density and the dealing with the septic tanks. And so one of the ways that we sort of targeted our priority areas is we looked at the septic tank distribution throughout the basin. So all these purple dots here, kind of red dots here that you see, these are all parcels that have, we're assuming, 1 septic tank on each parcel. So that's a conservative estimate. And then these sort of red to pink blobs that you're looking at, these are sort of density clusters where we see the highest density of septic tanks together. And so we can compute with these data, we can take a look at how many septic tanks are in each sort of density cluster, but we can also break it out by county, and we can look at how many septic tanks are in each county. And this is actually a really powerful analysis, because let's say that we do find a hotspot area like this area in Polk County that's right just west of Lake Hancock. We can actually go in, we can surgically count exactly how many septic tanks are in that area. If we know a cost associated with a septic to sewer conversion or a septic upgrade, we can do sort of a like napkin calculation. If we want to remove, let's say, 80,000 septic tanks out of a particular area at $30,000 septic tank, you can see how the numbers are going to add up into the hundreds of millions of dollars, like really, really quickly, right? But it's a pretty powerful tool to kind of give you a targeted look at where are we seeing a lot of this nitrogen being generated. And it was actually this work that prompted another study to happen in parallel with while we were working on the Peace River Basin model, where we got asked to take a look at the entire distribution of all of the septic tanks within the state. So the work that we did in Peace opened up everyone's eyes to taking a look at what is actually going on septic-wise in the state. We counted with this work that we did about 1.8 million septic tanks. And again, that's a really conservative value across the entire state. Now, we did a little bit more of an in-depth analysis when we did this, where we found that nearly 40% of those septic tanks are over 40 years old, and about 19% of those septic tanks are located within 150 feet of a water body. And so this sort of brought even bigger attention to the fact that while we do have multiple sources of nutrients within our basin and in our state, we do kind of have this like huge problem of a gross amount of very aging septic tanks within our state that are very close to our waters. And so out of this report, one of the things that we did was we ranked which counties across the entire state had the highest risk. And just by sheer serendipity, Polk County was the #1 county of the highest risk of septic. They actually, on our risk scoring system, came out to be the worst county in terms of septic risk for the entire state, followed by Orange County, and then Lee County is #3. And both of those counties are definitely connected to our estuary here in Charlotte Harbor. And so I think that kind of really drove home, this issue and how important it is that we really focus on this issue. And I know there's been a lot of work in this region that's been done already. And I know people are also working in Lee County to do these septic removals. There's a lot of work going into that. And I would just say that I think that's a good thing and that we should definitely continue to support that effort. The state does have a full list by county of how many parcels are in every single county. The list is ranked by worst county to the least worst county. It gives exactly how many septics are in there. And I'm just going to go back a second. There are maps that the state now has where we have highlighted areas where we would prioritize the red first, then the orange, and then the yellow. And again, this is based on the most updated public data set of septic systems. So we do know that some septic systems have been removed since then, but we're working with the most available data set that we had at the time. I just wanted to kind of mention the septic stuff. I'm going to go back into the piece now. And so one of the things that we did was once we kind of did a couple of the scenario analyses in the model, the top table here is showing you the scenario analysis with septic to sewer conversion. And the bottom table here is showing you the scenario analysis for the 6 constructed wetland projects. We actually went back in the model and we removed the septic out of our hotspot areas and recomputed how much nitrogen would be removed through the system, and then attached a dollar price to that change, and then estimated basically at the end of this table here how many dollars it would take to remove a pound of total nitrogen and a pound of total phosphorus from the system based on these prices and based on how much we computed came out when we removed those septic systems out of the model. And so for septic to sewer conversion projects, we estimate that it costs about $174 a pound of nitrogen to be removed in low density residential areas and $100 per pound in medium density areas. And for phosphorus, it's about $8,000 per pound. That's because septic tanks don't really generate that much phosphorus, so you have to do more to get the pound out, $8,000 and $4,000. For wetland projects, we found that there was a lot more cost savings. It was only $19 per pound to implement this wetland at site 1. We did have at site 2 $135 a pound. These different sites cost different amounts of money. These wetlands are different sizes and they're different engineering challenges to construct them. That's why these prices are different. But we found overall that it's, constructed wetlands are actually a lot more cost effective for nitrogen and phosphorus removal than actually septic to sewer conversions. Not that we're not recommending not doing that. We're just looking at the cost benefit and try to normalize that analysis. But we realize that there's a mix of approaches that are going to be needed in order to meet those water quality goals. And so one of the things that we're trying to do is explore all the different project types that we can actually put into the model and rerun the model to address the different, point sources of this surface nutrient loading. And so that's something that the team is kind of starting to understand and work through and figure out ways where we can really optimize the model to these different kinds of commonly used projects to mitigate the water quality issues. And so I just kind of want to conclude a little bit about the model is that we have this WAM model for the Peace River Basin. This is something that DEP can use for hopefully in the future a basin management action plan for the basin. We've integrated land use and we've modeled surface loading. We've also looked at 23 years of data to model this. We hope that it helps highlight hotspots, including this area next to Lake Hancock and Polk County, as well as some areas in the central part of the basin of where we see these high nutrient loads coming from, and that we are, basically presenting some project recommendations that can be taken seriously for mitigation. We are still wrapping this whole thing up. So this month, all of our reports are getting consolidated and getting refined. We're getting ready to submit all of those to DEP. We have another publication coming out, which is the scenario analysis part of the WAM model. We also did a data gaps analysis for the Peace River Basin. That paper will hopefully be coming out next year as well. We have a team working on a hydrodynamic model for the basin. So there's a lot of work still to come for Peace River. And while this is happening, happening, we're constantly kind of looking at, okay, what are we learning from developing this methodology? What do we need to improve? What do we need to change? What do we need to add? And so this conversation has been going on while we're doing this work. And we proposed expanding out this analysis to additional basins. And so we did get greenlit with some funding now to step out into additional basins. And so although it's quite political and who knows, it's kind of a hot potato and it could change any day, we have right now funding in place to move out into all of these other basins using a similar methodology. So as we step out, we will identify stakeholders. We'll try to do a comprehensive watershed analysis with those stakeholders. We're trying to identify data collection needs, data gaps. We may do a WAM model for each one of these basins. In some cases, we may end up doing an HSPF model or utilizing an already developed HSPF model if DEP has one of those to conduct our scenario analysis. So we're kind of adding on some more consultants so we have some more arms and legs so we can approach each one of these sort of unique basins in a different way. And then the other part of this that's happening is that we're taking all of this information and we're trying to get it hosted up onto a dashboard that we can eventually share with the public. And we're really not sure how we're going to do that yet, where we can have all of this data that we're compiling in one spot. So you can go in and you can look at a basin overview. You can see the stakeholders, you can see the major impairments and mitigation efforts. You can look at the land use, you can look at the septic distribution, you can look at the wastewater permitting. You can get a snapshot of the water quality analysis and look at the recommendations and the key insights that we're getting from our analysis. So working with our technical partner on getting that developed. And the vision ultimately, if we can get recurring funding to do this, is to step out, across the state. But we have a priority to our region. And so our priority at the moment is really focusing on these watersheds that feed into Charlotte Harbor so we can get a comprehensive regional understanding of what is happening with nutrient loading on the surface for this area. And so I just kind of want to mention there's a ton of people that are working on this project. This is not even everybody. I mean, this is just sort of a snapshot in time, but it's a huge team. I'm kind of working with all of the different teams to kind of bring together the work. I'm sort of the bridge between FGCU and DEP. I am working directly with the legislature. I have got a chance to meet with the senator a couple of times and present this work. And so it's just been quite an honor and such a learning experience for me as a new professor to be down here in this region, serving the region and learning about how hydrology works. Brandon.
I really appreciate the work. I have obviously lots of little questions, but I want to kind of bring up just two big ones, broad ones, in front of this group. And that is, so when we're talking about the Peace River Basin, we've got much of the main stem piece that either is or is being proposed to be put on the non-attainment list for exceeding the nutrient numeric threshold, right? They're going on the study list because bioassessments have been done. But they're at least, exceeding the numbers, right? You mentioned. DEP has not given any indication about, assuming that the bioassessments come back compared and some of these get thrown on the verified pair list. There's not much indication of DEP looking at doing focus remediation strategies down here, whether that's TBLs or whatnot. And I've been trying to have and have had a couple of sidebar conversations with some of the counties in this region about what can we do to enact some of these recommendations, right? So it's great that we see that there's areas with, a lot of septic tank issues, BMPs could be implemented. I remember in the article that y'all published that in reference to the phosphate mining that there was a particular emphasis on those relic lands that were mined post or pre reclamation requirements, that sort of thing. So what sense, if any, have you gotten from DEP on the the management implications or funding implications that could come from this work. In other words, if we were to say, FGCU did this great thing, K-State give us money because right now we're at a competitive disadvantage from a lot of state grants because there's not team deals, there's not BMAPs, there's not, and those are things that are scored out in those competitive processes. So I'm wondering how this can be utilized, and the DEP has given any indication on sort of how they view your work in terms of next steps and what they're going to do. And then also, how in the world can we help you take this work that you're doing and push DEP to further consolidate their data sources so that, because there's so much data in this basin that's not in play. And I think we would get an even better picture of sources and issues if that data was pushed in there. And I suspect that that's a result of just general siloing in different departments and the way the processes have just kind of emerged over years in terms of how permit data is handled and this, that, and the other. But it drives me up the wall that we see these gaps that we're having to make kind of assumptions about what's happening in that area when there's actual data that exists. And I completely understand why I went to focusing on web data. It's established, requirements for how the data gets in there, how it's processed, viewed a certain way, vetted to a certain extent. So it's not, I am not attacking how y'all did it, but I'm just wondering how can we really kind of get all the data that's out there that already does meet those standards and get it all consolidated so that y'all have that available to you for these kind of studies.
Yeah. So the first question that you asked was about, have I gotten any indication about the region having any TMDLs established or what was happening with that?
DEP, with indications on how they intend to utilize the work that you're doing
Yeah. So I don't know. The potato got passed to us and Peace River Basin was the spot. And so we started getting to work. That was the first thing that we did. And then through this, what has been constantly repeated to me by multiple places is part of the reason why this is happening, that the legislature has asked for this, is because work is not getting done fast enough in the state, and that maybe this is an opportunity to help, right? So this is sort of like the one side. And so we want to help DEP, we want to support DEP, we want to do good science, right? And so some of the conversations that we had with DEP is, how can we do this so that you can use this information? And so they've given us requirements. We've had to have co-ops for the model. We've had to have, all these different things. We've met with them. They haven't agreed with everything that we've done, but we try in every instance to be flexible. And if it's a reasonable request, of course, we're going to do it. We want that information to be of value to them. So what I'm hoping, because a WAM model they've used before in other watersheds, so it's not like it's a complete foreign body for them to use for establishing some of these criteria, that they'll be able to take everything as we're wrapping up the watershed and be able to make some decisions and have all of that information right there so that they can, move forward with it. And I think we need to just make sure that we are emphasizing that on the legislature side too, that, hey, look, state just invested all of this money in this project and we're handing it over to DEP. We've worked with them, we've tried to make sure that we're following and doing things the way that they would want it to be done. Now, what are you going to do with this, right? So I think we need to make sure that we don't forget to stress that and emphasize that. In terms of the other question with the data, I mean, I think, and I don't really understand exactly what all of this data is, how it's been collected. But, as we know, we have these SOPs, right? We have all of these things that we have to follow for data collection. So I imagine, and I don't know if I could be totally wrong about this, but in my mind, I think it's almost just there's DEP data, and then there's everybody else's data. And so if it's not DEP data, then why can it not be DEP data? And that's the question. And so if it's a matter of, well, it doesn't have these SOPs and it wasn't sampled this way, or here there were different ways, maybe it can't be in WIN, but maybe there's opportunities for it to be sort of an ancillary, set that's sort of tangential. I mean, and this is, something that I would love to hear your feedback on, because I would imagine that it's more about standardization than it is anything.
I think there's yeah. Thank you,
I
Brandon.
wanted to thank you for the presentation. I think this model has great potential, and understand the end game is to make public investment to improve water quality. And I also appreciate that you consider nitrate as a potential source. So I appreciate your coming before the PAC, and we have an opportunity to provide meaningful input. I'll provide some comments through them. But I want to touch on three things real quick that are kind of general and would apply to any model of this nature that, as you extrapolate, put it into other watersheds. The first is, real quick, I didn't notice in the paper for sources that you considered reclaimed water disposal, land application, and in much of Florida, I think this watershed too, very few of the wastewater plants are AWT, so that the amount of nitrogen that's being put out, and about, in my experience, 80 to 90% of the nitrogen is in the form of nitrate. So it's a real potential source of that being applied. And a lot of the models that I've been involved in and I've seen be developed in the region are looking at that as a source now. So that would be a really good thing to include as a source, particularly nitrogen and nitrate. The second, I wasn't going to mention, but there was a lot of discussion about septic tanks, and the paper does a really good job in those discussions and distinguishing between the hydrogeology, even in the Peace River Watershed, between flatwoods and groundwater moving quickly through soils, percolation, and movement of nitrate without any natural nitrification. So hopefully the model can similarly make that distinction. I understand the age of the septic tank is important, the proximity to water is important, but I would also say the hydrogeology of where the septic tanks are located is important. And it says it in the paper, I just don't know if the model is capable of making that distinction. And the final thing I wanted to mention, and kind of picks up on the previous comment, is it sounds like when I read through the paper that there are statements at the very beginning about, we can use data or we can use models. It's really expensive to collect data, so we're going to focus on the model. I would echo that, I think that there were only 3 or 4 water quality monitoring stations used, and there's like over 94 in this watershed. Now, all of them may not be applicable, but a lot of them are. And the same for flow monitoring. I think only 7 were used, but there's probably 24 USGS gauge stations. I've spent a lot of time in this region analyzing all this data over the last 40 years. And in particular, in this watershed, I would tell you, Joshua Creek, Horse Creek, I don't know why, but there's water quality data at that USGS station as well. And what it will tell you, my point is, if this effort or any effort spent time right out the bat analyzing the data that exists, it will tell you what the model should be telling you, okay? And so my concern is that I see certain instances where if you don't analyze the data, and Joshua Creek, I mentioned, is a really good example, where if you look at that data over the long term, what it's going to tell you is that there is an abnormally high percentage of the nitrogen form of nitrate, or dissolving organic nitrogen. About 45% of the nitrogen in the water, not the land use, up to the land use is higher. And it's probably, legacy citrus. So I noticed in the paper too that agriculture has just one category, right?
Yeah, they have looked at the subcategories as well. Yeah, they do go that granular, but I think for the report they've kept it in the general category.
I think that for some of these row crop or citrus, the nitrate concentration application land it could be much higher. And that's what the data shows. So it's what I think the maps are wonderful for lay people, for politicians. But if we're going to be investing public money, and in this age of Doge, we need to make sure that the investments are pinpointing the right solutions. And I just, on the maps, I see that Joshua Creek is just low. It has no nitrate. And we know from just looking at the data, it's the case.
We're happy to, we will be happy to share the final reports with you when they're done, and happy to circulate that through for you. But going back to the issue about the granularity, I will double check with the modeling team on the septic question, and if where the assumption is being made on the average depth of the septic, because I think my guess would be there's probably some general number where they're like, okay, the septics are probably around this depth, they're buried around that. That would be my guess, but I don't know, so I'll double check with them.
State law is required since 1984 in this region. Septic tanks have drained for 2 feet above the water table. So you have the whole intent was to make sure that it's nitrified.
Right.
Okay. But in this area, as pointed out in the paper, the geology is such that you have long travel times in a anaerobic environment. And if there's any organic carbon in the soil, you'll get that. And I've seen this at data. I've looked at a lot of data in this area, and I see it everywhere. In fact, I've yet to see this in the case in this area.
Well,
but up in Orlando and Polk County, yeah, I'm sure that the nitrate's moving pretty efficiently.
Yeah, and take into consideration the soils and the draining of the soils.
Sorry to interject. I know we are on a tight schedule here, so I just want to say first, thank you so much for sharing this. And I think you see the breadth and depth and passion of this group, who many are very familiar and have worked a very long time in this basin, and so have a lot to offer. And so I appreciate you sharing this, and I hope that each person will take advantage now of having you here to talk a little bit more after the meeting with you directly. I would also say, though, just as a side note, as someone who spent many years as a lobbyist in policy as well, that, you know, the next step of where you're headed with forming recommendations, you know, very important, very, very critical. You know, the science is great, and it's incredibly important, but the way that we message science is equally important in making sure that the right takeaways are gathered from the audience that we're going to convey this to. And I would encourage you, like, for instance, on the cost benefit analysis, really intriguing. And I do appreciate, like, constructed wetlands, you know, in some cases might be more cost effective than septic to sewer. But when you see the map of, like, Port Charlotte rising up as one of these hot spots, and it's right downstream on the harbor, there are obviously exceptions where constructed wetlands, there's not always the opportunity for those. And so the investments that, for instance, Charlotte County is making are very important. And we want them to, if anything, get reinforced and reinvigorated in continuing to make those investments by your work, and not be like, oh, well, we're investing in the wrong thing. We should be doing constructed wetlands somewhere else. So I think if you are amenable to it, you know, we would like to invite you to come back and represent as you continue to develop some of these things, like the recommendations or whatever, to maybe before those are finalized, share those, and then there might be some useful input from the TAC